Hello Gators, this is 7-5 Proportions in Triangles, Day 2. Let's take a look at one other theorem that has to do with proportions, and that's called the triangle bisector theorem. And the triangle bisector theorem goes like this. If you have an angle bisector, the angle bisector is going to cut the side into two parts. We'll call this part 1, and we'll call this part 2. And the two parts will be cut in such a way that it'll be the same ratio as the ratio of the sides. This will be side 1 and side 2. So it's saying that side 1 is to side 2, side 1 over side 2 equals CD, which is part 1 over part 2. So that's what the theorem is saying. Now, we can write ratios in different ways. We could write it side 1 over side 2, or we could write it as side 1 over part 1, side 2 over part 2. These two have the same ratio because when you cross multiply like this, you're going to get the same product. You're going to get side 1 and part 2 getting multiplied, part 1 and side 2 getting multiplied. So why does this work? Well, here's why this works. We're going to take a look at this picture, and we're going to make this side longer, and we're going to make it so long so that at one point we're going to be able to draw a line from that point to B, and it's going to be parallel to this side, and that's what I have drawn over here. And when we do that, we're going to call this point point E. Now, when we do that, we have side splitter. I want you to notice you have upper to lower, and that's what this is right here. This is upper to lower, and I want you to compare that with what we're trying to prove. We have all the same thing, except this is not the same as that. AB should be here, and we have an AE. So let's talk about how we can get this to become AB. Now remember, these lines are parallel, so we know this angle and this angle are the same, and that's because if two lines are parallel, corresponding angles are congruent. And these are alternate interior angles, so those are going to be congruent. So these two angles are the same because they come from two angles that are the same. Now when these two angles are congruent, that forces these sides to be congruent. This is the base angles theorem. If two angles of a triangle are congruent, then the sides opposite. So this is telling me that AE is equal to AB. So we're going to take AE out of here, and we're going to put AB in its place, and that's what we want right here. So that's why this theorem works. So we're going to, you can do side 1 over side 2, part 1 over part 2, or you can do any combination that allows us to have the same cross multiplication product. So I'm going to count this as side 1, and I'm going to count this as side 2, and this will be part 1, and this will be part 2, and part 2 will be 13 take away x, because 13 is the whole length, and 13 minus x will be how long this part is. So side 1 is 10, part 1 is x, side 2 is 16, and part 2 is 13 minus x. I'm going to cross multiply. 10 times 13 minus x equals 16x. I'm going to multiply. That's 130 minus 10x is equal to 16x, and then I have 130 equals 26x, and so x will be equal to, and it's going to be 130 divided by 26, and that'll be equal to 5. So that x is 5, so AD will be equal to 5, and CD will be equal to 13 minus 5, which is 8. So those have to add up to 13. All right, let's go ahead and do it again. I'm going to call this side 1, and I'm going to call this side 2, and this will be part 1, and this will be part 2. So I'm going to do 18 over 12 is equal to 3x plus 3 all over 3x minus 7. And so I'm going to do 18 times 3x minus 7, and this will be 12 times 3x plus 3. So that's going to be 54x minus 126 equals 36x plus 36. I'm going to subtract 36 on both sides, and subtracting 36 on both sides, I get 18x minus 126 equals 36, and I'm going to add 126 on both sides, and that's 162, and then I'm going to divide that by 18, and that'll be equal to 9. So I've got what x is equal to, it's 9, so GH will be 27 plus 3, which is 30, and GK will be 30, let's see, did I do that right? 27, but this time I'm going to subtract 7, so that'll be a 20. All right, now let's take a look at this problem. This is not, this is a review from yesterday. This is side splitter. Notice that the parallel lines are cutting these two sides into upper and lower, upper and lower. I'm going to call this upper 1, and this is, I'm going to call lower 1, upper 2, and then this will be lower 2. So it's x over 5 equals 9 over 3. And so this will be 3x is equal to 9 times 5. I'm not going to multiply it out. I'm going to divide both sides by 3. And then I'm going to do some reducing. 3 goes in here once, 3 goes into here 3 times, and so the answer is 15. Let's take a look at this problem. This looks like mid-segment theorem, and mid-segment theorem would mean that this is in a 1 to 2 ratio, 1 to 2 ratio, so this will be in a 1 to 2 ratio here, so the answer will be 14. This is an upper to lower situation, so I'm going to consider this upper 1, lower 1, upper 2, and this will be lower 2. So this will be 12 over 16 equals x over 13. I'm going to cross multiply. 12 times 13 equals 16x. I'm not going to multiply out. I'm going to divide both sides by 16 and do some reducing. 4 goes into here 4 times, 4 goes into here 3 times, so the answer is 39 over 4. And you can leave it as an improper fraction. All right, here's our new material. This is angle bisector, and remember we get proportions out of there. I'm going to call this side 1, and this is going to be called side 2. This is going to be called part 1, and this is going to be part 2. And I'm going to set up the proportion. 30 over 24 equals 20 over x. I'm going to cross multiply. 30x is equal to 20 times 24. I'm not going to multiply it out. I'm going to divide it by 30 and do some reducing before I do any multiplying. So 10 goes into here 3 times, 10 goes into here 2 times, 3 goes into here 1 time, 3 goes into here 8 times, so the answer is 16. And let's go ahead and go through the summary. We did side splitter theorem. Remember, it's when a line parallel to a third side divides the side into parts, and these parts have the same ratio. We also looked at mid-segment and the fact that this creates parallel lines, and the fact that we have that 1 to 2 ratio. And this was our last theorem, the triangle angle bisector theorem, where we get the side in the part, and the side and the part in the same ratio. And there are other ratios that work as well.